At this point, we should be familiar with the common functions. For instance, let's just go ahead and give those to ourselves real quick. So you can graph pretty complicated functions by understanding the graphs of simple functions, right? The identity function, y is equal to x, is just the straight line where all of these y values are equal to their x values, right? Slope of 1. X squared looks like this. As you move away from the origin, your values increase, but they're always positive because you're squaring something. You can think about x cubed, has the same shape, except it's a little bit faster than the x squared function. And then your negatives stay negative, right? Because if you cube something that's negative, your negative sign is still there. You've got the absolute value of x, which gives you x if it's positive, gives you negative x if it's negative. You've got the square root of x. You can only take square roots over positive numbers. You've got the cubed root of x. But you can also take the cube root of negative numbers. Am I missing one? Maybe the constant, maybe y is just equal to some number. So that's just y is always equal to whatever that c value is. So if you understand the simple functions, we can graph what's known as piecewise defined functions. So this is where we define a function depending on which part of the domain we're looking at. So these are if statements. If x is less than 0, you look like the x function. So these are where your x values are less than 0, right? It's the left-hand side of your plane. So when x is less than 0, when you're over here, then your function is equal to x. So you get that straight line, right? Because that's the line y is equal to x, and it only exists over the negative numbers. And then your piecewise function tells you that for positive numbers and for 0, you're supposed to look like x squared. So at 0, 0 squared is 0. And then you look like the x squared function for positive values. So for all of these x values, you look like x squared.